Hi everybody. Welcome to my simple channel. On this occasion, I will share information about rockets, starting from the history of their discovery, the research and testing process that took so long, and their current developments. Without further ado, let's watch the video.
In the previous discussion, we already knew at a glance how rockets are found and researched. In this video, we will discuss some new information about rockets. The first is the part and function of the rocket engine. Nose. The front part, which is usually filled with the scientific payload warhead or sensory or control equipment. Cylindrical tube, cylinder, the main body of the rocket, which is usually filled with fuel, and its fuel equipment. The rear part contains the combustion source channel, nozzle, control mechanism. Fins. Fin, stabilizer, aerodynamic control device, which functions as a provider of steering and stability. The frame, or rocket body, rocket frame, is made of lightweight and strong materials such as titanium and aluminum because the frame serves as a protector. The rocket body is also covered with a special coating to protect it from excessive heat when it penetrates the Earth's atmosphere and from excessive cold. Fins are attached to the underside of the rocket to maintain stability during launch. The load system is a place to carry the rides, so this system depends on the mission carried out by the rocket. If it is to orbit a satellite, the design must also be adjusted. The guidance system is a tool that will guide the rocket to its intended orbit. This rocket guidance system is equipped with sensors, computers, radar, and communication devices. The propulsion system is the engine used to propel the rocket. The rocket propulsion system in general uses solid fuel rockets and liquid fuel rockets. The V2 rocket propulsion system consists of an oxidation tank, pump, combustion chamber, and nozzles. Current technological developments are growing very rapidly, one of which is rocket technology, which is currently growing. A rocket is a kind of propulsion system that carries its own fuel and oxygen. Rocket technology is an interesting application of Newton's third law and the conservation of momentum by emitting a mass stream of propellant combustion products. The rocket has tanks filled with liquid hydrogen and liquid oxygen fuel. The fuel is burned in the combustion chamber to produce gas and then discharged through the nozzle, which is located behind the rocket. As a result, there is a change in the momentum of the gas during a certain time interval. Nozzle. D from Newton's third law, when an object exerts a force on another object, then the object exerted by the force will exert a force on the object exerting a force on it. This force is called an action-reaction force, which has the same magnitude but the direction is opposite, and also impulses and momentum. It is said that an external force acting on an object, or Werner von Braun's system, will result in the rate of change of the object's momentum. Rockets can launch vertically upwards because they have a propulsion engine that can give them speed. Rocket thrust works based on the impulse given by the rocket engine. When the rocket is moving, the law of conservation of momentum will apply. Hydrogen and liquid nitrogen rocket propulsion engines, the two fuels mix in a combustion chamber, then produce hot gas that comes out of the tail of the rocket. Before the rocket is ignited, its momentum is zero. After the fuel inside is ignited, the gas jet that comes out of the tail of the rocket will push the rocket into the air. This applies to rocket motion, the law of conservation of momentum. Therefore, initially, the system is at rest, there is no gas dispersion, and the rocket is still, its momentum is zero. After the gas gushes out, the rocket moves. The momentum of the system after and before the gas is ejected is constant. Rockets are spacecraft, missiles, or flying vehicles that get a boost through the rocket's reaction to the rapid release of fluid material from the rocket engine output. This rocket also contains solid rocket fuel or chemical liquid fuel, which combine to provide a large thrust so that it can escape the Earth's gravity at nearly 11 km/s. Rockets are not only used for military purposes but also for science, communications, and even for humans to land on the moon. As technology advances in different parts of the world, so does the size of the rocket. V2 is a rocket used by Germany in World War II, made by Werner von Braun, that reached the atmosphere. The Saturn V is the world's largest and most powerful rocket ever built in human history. This is the rocket that made it possible for humans to land on the moon. The Saturn V is nearly 363 feet tall as a 40-story building. The N-1 is a moderately powerful rocket and the largest rocket developed by the Soviet Union to send people to the moon. But all of these rockets were destroyed during their test flights. N-1 is about 344.5 meters long. Ares-1 is another US-designed rocket currently under construction. After retiring from the shuttle, Ares will be the transportation for humans to go to space and even to the moon again. Ares-1 was 310 feet long and powered by a single solid rocket engine during liftoff. The Delta IV is a US-designed rocket intended for military and commercial use. This rocket has a height of 206 meters. Atlas V is a rocket made in the United States designed to carry heavy loads into Earth's orbit. This rocket has a height of 195 feet and a total lift of 333,298 kilograms. The Ariane 5's first failed flight test was in June 1996, with a self-destruction 37 seconds after launch due to a fault in the control software, which is without a doubt one of the costliest computer bugs in history. This rocket has a height of 193 feet. Made in the USA, the Space Shuttle is often used for the delivery of medium-sized cargo into orbit and is operated by a crew of 7 men. The Space Shuttle is 184 feet high. The HIIB is a liquid-fueled rocket made in Japan that provides a launch system for the primary purpose of launching the H-2 Transfer Vehicle, HTV, to the International Space Station, ISS. This rocket has a height of 56 meters. The Dnepr rocket is a converted ICBM used to launch satellites into orbit and is operated by launch service provider ISC Kosmotras. The first launch, on April 21, 1999, successfully placed UOS AT-12, a 350 kilograms mini-demonstration satellite, at a circumference of 650 kilometers in low Earth orbit, LEO. One of the goals of rockets being launched into space is to send satellites that can function as human communication aids on Earth, such as TV broadcasts, telephones, and so on, all of which can be used because of satellites launched into space. A satellite is an object orbiting another object with a certain period of revolution and rotation. There are two types of satellites: natural satellites and artificial satellites. The first man-made satellite was Sputnik 1, launched by the Soviets on October 4, 1957, and starting the Russian Sputnik program with Sergei Korolev as chief design officer and Kerem Kerimov as assistant. This launch sparked a space race between the Soviets and Americans. Sputnik 1 helps identify the density of the upper atmosphere by measuring changes in its orbit and providing data on the distribution of radio signals in the ionosphere. Because the satellite's body is filled with high-pressure nitrogen, Sputnik 1 also provided the first opportunity for meteorite detection because the loss of internal pressure caused by meteoroid penetration can be seen in the temperature data it transmits to Earth. Sputnik 2 was launched on November 3, 1957, and carried the first living creature into orbit, a dog named Laika. In May 1946, Project RAND issued a preliminary design for an experimental world-circulating spacecraft, stating that a satellite vehicle containing the appropriate instrumentation can be expected to be a powerful scientific tool for the 20th century. America has been thinking about launching orbiting satellites since 1946 under the Bureau of Aeronautics of the United States Navy. The U.S. Air Force's Project RAND eventually issued the above report but did not suggest that the satellite had potential as a military weapon. However, they regard it as a tool of science, politics, and propaganda. In 1954, the U.S. Secretary of Defense stated, "I am not aware of any American satellite program." On July 29, 1955, the White House announced that the United States would want to launch a satellite in the spring of 1958. This became known as Project Vanguard. On July 31, the Soviets announced that they would launch a satellite in the fall of 1957. Following pressure from the American Rocket Society, the National Science Foundation, and the International Geophysical Year, military interest increased, and in early 1955, the U.S. Air Force and Navy worked on Project Orbiter, which used a Jupiter probe to launch the satellite. The project was a success, and Explorer 1 became America's first satellite on January 31, 1958. In June 1961, 3.5 years after the launch of Sputnik 1, the U.S. Air Force used the facilities of the United States Space Surveillance Network to catalog the 115 satellites orbiting the Earth. The largest man-made satellite currently orbiting the Earth is the International Space Station. A satellite is an object in space that rotates following the Earth's rotation. Satellites can be distinguished based on their shape and uses, such as weather satellites, communication satellites, science and technology satellites, and military satellites. To be operational, satellites are launched into orbit with the help of rockets. Developed countries such as the United States, Russia, France, and recently China already have stations to launch satellites into orbit. All satellite movements are monitored from the Earth, better known as the control station. The way the satellite works is by way of uplink and downlink. Uplink is the transmission sent from the Earth to the satellite, while downlink is the transmission from the satellite to the Earth station. All satellite movements are monitored from the Earth, better known as the control station. The way the satellite works is by way of uplink and downlink. Uplink is the transmission sent from the Earth to the satellite, while downlink is the transmission from the satellite to the Earth station. Satellite communications basically function as repeaters in the sky. Satellites also use a transponder, which is a tool to enable two-way communication. In general, satellite communication uses many transponders. At present, it is able to accommodate communications in Asia and Africa. Satellite antennas play a very important role in satellite communication networks, because this object functions as a transmission receiver in every region of the world. Meanwhile, satellite spacing is used to make transmission easier based on the region. While the power system used by satellites is obtained through sunlight, which is converted to electricity using solar cells, in addition, the satellite is also equipped with a 12-year power source, which is the fuel it needs to operate. Astronomical satellites are satellites used to observe distant planets, galaxies, and other celestial objects. A communications satellite is an artificial satellite installed in space for the purpose of telecommunication using radio at a microwave frequency. Most communications satellites use a geosynchronous or geostationary orbit, although some newer types use low Earth orbiting satellites. Navigation satellites are satellites that use radio signals routed to receivers on the ground to determine the location of a point on the Earth's surface. One of the most popular navigation satellites is GPS, which belongs to the United States. Besides that, there is also GLONASS, which belongs to Russia. If the view between the satellite and the receiver on the ground is uninterrupted, then with a satellite signal receiver, GPS receiver, position data can be obtained somewhere with an accuracy of several meters in real time. A spy satellite is an Earth observation satellite or a communications satellite used for military or espionage purposes. A solar-powered satellite is a satellite proposed to be built in high Earth orbit that uses microwave energy transmission to beam solar energy to very large antennas on Earth that can be used to replace conventional power sources. A space station is a man-made structure designed for human habitation in outer space. The space station is distinguished from other spacecraft by its lack of main spacecraft propulsion or landing facilities, and other vehicles are used as transportation to and from the station. The space station is designed to live in orbit for periods of weeks, months, or even years. Weather satellites are satellites used to observe Earth's weather and climate. Miniature satellites are light and small satellites. A new classification was created to categorize these satellites: mini-satellite, 500–200 kilograms, microsatellite, under 200 kilograms, and nanosatellite, under 10 kilograms. One of the reasons for the miniaturization of satellites was to reduce costs. Heavier satellites required larger rockets with more thrust, which also cost more. In contrast, smaller and lighter satellites require smaller and cheaper launch vehicles and can sometimes be launched in multiples. Observation satellites are satellites specially designed to observe the Earth from orbit, similar to spy satellites but intended for non-military uses such as environmental surveillance, meteorology, map-making, and others. Many types of observations can be made from satellites, including military reconnaissance, terrain mapping, astronomical photography, international inspections, cloud observations, and Earth photography. Observations can be made in many ways using sensors that operate in different parts of the electromagnetic spectrum. The first sensor used by humans was the naked eye. Next came photography, with its ability to record large amounts of permanent, detailed information. Then followed the development of reconnaissance radar, electronic interception, and infrared reconnaissance. Space observatory. A space observatory is any instrument in outer space that is used to observe planets, galaxies, and other planetary bodies. Several observatories have been launched into orbit, and most of them have greatly expanded our knowledge of the cosmos. Astronomical observations from Earth are limited by the filtering and interference of electromagnetic radiation due to Earth's atmosphere. Therefore, sending observatories into outer space is necessary. As a telescope orbits the Earth outside its atmosphere, it is not subject to twinkling. Space-based astronomy is even more important for reaching frequencies that lie outside the optical and radio windows, the two wavelength ranges of the electromagnetic spectrum that are not diminished by the atmosphere. For example, X-ray observations are nearly impossible from Earth and have reached such an important place in astronomy only because of orbiting satellites equipped with X-ray telescopes such as the Chandra Observatory. Space observatories are generally divided into two classes: missions that map the entire sky and observatories that make observations of specific parts of the sky. Many space observatories have completed their missions, and others are still operating. The satellite has been launched by NASA, ESA, and the Japan Aerospace Exploration Agency. Active and passive satellites. Passive satellites are satellites that reflect the electromagnetic radiation they receive without modification or amplification. Passive satellites cannot generate power but only reflect the power they receive. Active satellites are satellites that can transmit power. They can amplify or modify the received signal later for transmission. Satellites are celestial bodies that do not have their own light source and move around certain planets while following the planets in circulation. For example, the Moon, which is a satellite of Earth. The movement of satellites orbiting the Earth in general follows Kepler's law, Keplerian movement, which is based on several assumptions, namely that the movement of satellites is only influenced by the Earth's central gravity field. The satellite moves in a fixed orbit plane in space. The mass of the satellite is insignificant compared to the mass of the Earth. The satellite moves in a vacuum, and there is no sun, moon, or other celestial bodies to affect the movement of the satellites. Orbits are the types of places where satellites circulate around the Earth's surface. In the context of satellite geodesy, information about satellite orbits will play a role in several ways, namely, position determination. To calculate satellite coordinates, which are later needed as fixed point coordinates in calculating the coordinates of other points on or near the Earth's surface. Observation planning. To plan satellite observations, optimum observation time and length, receiver aiding helps speed up the satellite signal receiver, to find the satellite in question. Satellite selection to choose, if necessary, geometrically better satellites to use. Data transmission media using satellites is an interconnection of data communications using satellites that are placed outside the Earth's surface at a certain height, where the signal carrier uses certain frequencies emitted from stations on the Earth and reflected by satellites to be directed to other Earth's surfaces as long as they are still within coverage the satellite area. For the implementation of communication, the satellite must orbit or surround the rotating Earth. The orbit used is the geosynchronous orbit, whereby a satellite can reach a third of the Earth at a height of 36,000 kilometers from the Earth's surface. A satellite that reaches a height like this has a trajectory around the Earth for 24 hours, so it will always appear stationary at a point on the Earth's surface. Satellites using this orbit are very profitable, namely because the cost to control the satellite is relatively lower and the connection is never broken. The Intelsat and Palapa satellites are examples of satellites that use geosynchronous orbits. How the satellite works in a conventional system specifically, by sending a signal from a computer and relaying it by satellite without processing it on the satellite. The weakness of this method is that the computer that is directly connected to the satellite must work for 24 hours. If one of the computers is turned off, then the connection to that computer will be lost. The advantage of conventional communication satellites is that they can be used without modification. The computer in the satellite functions to temporarily store information, which can be done automatically. How data transmission works via satellite. Utilization of satellite communication systems has provided the ability for humans to communicate and obtain information from various parts of the world simultaneously, regardless of their relative distances. The basic components of a satellite transmission are an earth station, used to send and receive data, satellites, also known as transponder, PC, that use internet networks with satellite networks are categorized as wireless networks using microwaves. These microwaves will be transmitted and processed by the Earth satellite station, which will then transmit them to the satellite in outer space and receive them back from the destination Earth satellite station. The workings of data transmission via satellite are explained by taking into account these components, namely, the satellite receives a signal from a ground station, amplifies the signal, changes the frequency, and retransmits the data to another receiving Earth station. In satellite transmission, there is a delay because the signal has to move towards space and back again to Earth. The lag time is about 0.5 seconds. Satellites use different frequencies to receive and transmit data. A communications satellite is an artificial satellite installed in space for the purpose of telecommunication using radio at a microwave frequency. Most communications satellites use a geosynchronous or geostationary orbit, although some newer types use low Earth orbiting satellites. For fixed services, communications satellites provide a technology complementary to fiber optic submarine communications cables. For mobile applications, such as communications to ships and aircraft, where other technological applications, such as cables, are impractical or impossible to use. Each satellite requires a power source. Factors to consider are cost, durability, and effectiveness, the amount of power generated. Satellites consume a lot of electricity. Placement of power resources installed inside or outside the satellite. Some possible power sources for satellites include solar panels, battery, nuclear power, heat generators. Indonesia also has satellites that have flown into space. Recently, a satellite was launched into space whose position is expected to be in the sky over Papua. One of the goals is equitable development in the field of information and communication infrastructure. The Republic of Indonesia 1, or Satria 1, satellite was successfully launched into space on June 19 in the morning at 5:21 WIB, or 18:21 Florida time, United States. Satria 1 is Indonesia's first internet satellite launched with SpaceX's Falcon 9 rocket from Cape Canaveral, Florida, United States of America, US. Prior to being transported to Florida, Satria 1, which is a satellite produced by PT Satellite Nusantara 3, was built at Thales Alenia Space in Cannes, France. Almost without incident, Space Exploration Technologies Corporation, SpaceX, launched this communications satellite into orbit from Florida on Sunday at 18:21 Eastern Daylight Saving Time or Monday at 5:21 WIB. The launch of Satria 1 was delayed 17 minutes from the original schedule at 18:04 local time, or Monday at 5:04 WIB. The flight delay was due to strong winds. I can't use it right away. Satria 1 will be monitored by Thales Alenia Space to ensure all devices function properly. Hopefully all the devices in Satria 1 can work well with the solar cells and their antennas, and can be controlled from the ground station. CEO of PT Pacific Satellite Nusantara, PSN, Adi Raman Adiwoso, added that Satria 1 cannot be directly used for internet as soon as it arrives in orbit. He said it took 145 days after launch for the test variety. This satellite is a very modern satellite, so it uses electric propulsion to go into orbit from the point where the satellite was released by the launcher, he explained on Tuesday, June 13. It takes 145 days, therefore, from the June launch on the 19th to the orbit in November, we will test the satellite first, and we will test the entire system so that it can be used around the end of December and is ready to be utilized for its services in January. Once Satria 1 reaches orbit and tests, the initial available 10 gigabits per second capacity will be used to serve public service points. Then gradually, according to the plan, in the next 3 years, capacity up to 150 gigabits per second will be used, he said. Focus on government offices. Marford explained that the aim of launching this satellite was to accelerate internet provision in government offices in locations unreachable by fiber optic networks in the next 10 years. I want to emphasize that the function of Satria 1 is to equalize internet access, especially for the purposes of education, health, public services, the community, the TNI, and the national police in all regions of the country, especially in underdeveloped, frontier, and remote 3T areas, he said in the video press release. Colinfo claims that the general public can also enjoy Satria 1 internet service. The trick is to hitch a ride on Wi-Fi services in these government offices. The public will be able to enjoy free internet services. This is broadcast by Wi-Fi, so people who want to use the internet can go to schools, to TNI offices, and hopefully they can reach their homes, said the Director General of Public Information and Communication of the Ministry of Communication and Informatics, Usman Kansong. Lifespan: 20 years. With a project cost of 8 trillion Indonesian rupiahs, the Satria 1 satellite has a lifespan of no more than 20 years. Adi Rahman said that the satellite becomes junk if it has exceeded its usage period. So all satellites that are not functioning will be stored in the graveyard orbit, he explained. He predicts that space debris from the Satria 1 satellite will slide back to Earth in the next 100,000 years. Maybe we won't be here anymore. NEED Ground Support Secretary General of the Ministry of Communications and Informatics, Mira Tayyiba, explained that her party had prepared communication infrastructure to support satellites. The form is in the form of ground segment Earth stations in 11 locations, namely in Cikarang, Batam, Banjarmasin, Tarakan, Pontianak, Kupang, Ambon, Manado, Manokwari, Timika, and Jayapura. We hope that the launch of Satria 1 can make the work of the Indonesian people easier and can provide equal distribution of internet services for people throughout the archipelago.
That's all for this rocket discussion video. Hopefully, this video can add to my personal insight and that of all my friends about rockets. Please comment, like, share, and subscribe to this video and channel. Hopefully, sharing can be an additional reward and source of knowledge for other friends. Thank you.